Hey people, welcome back. Thank you so much for joining. And this session, we will be learning about how to calculate the process capability when data is binomial distribution. Binomial distribution means you are looking for the defective proportion out of the total transaction done or the production done. So we are going to learn about what is binomial capability, discrete data. So what we need here, you need first what is the production of the transactions here that you have done. And out of these, how many transaction was defective transaction? And based on that, we'll calculate the proportion of the defective. And that proportion of the defective, we convert into the process capability. That's the way we do the binomial capability. Okay, so suppose you are working in a process on the daily basis, you are doing from 122 on an average 150 transaction per day. On an average, the transaction which is not able to run or non-workable transaction are suppose in between 12 to 20 you have, or maybe let's say you have from 5 to 20 transaction, which is the rejected one. This data you have for last, let's say this is around 22 working days data you have collected. And based on this data, you wanted to find out that what level of process capability you are performing. So we can clearly see here that you have the defective out of the total production, which means the binomial capability calculation is the best fit for such data. How to do this? Let me first tell you in Excel. So you will take the total of your transaction done in a month, which is 3017, and number of rejection are 265. Simply we'll take the proportion of the rejection here. So if you say percent defective is 265 divided by 307, which is 0.087884 of 1, or you can say around 8.78% defectives are there. If this is the defective, so what is your yield is coming? Yield is always 1 minus defective, which is around 91%. So the sigma level of this process or Z value will be, we are using formula norm sin V, 91.22 you have here, which means your process is performing at 1.35 sigma. If the current effective rate is your 8.78%, which means yield is 100% minus 8.78, 91.22%, and 91.22% output is equal to 1.35 sigma. Now I'll do the same calculation in Minitab. If I use the same data till here, I open the Minitab and I just simply paste this data in the Minitab. Here is the data table and we can see the data is here. Now what to do? Next, go to the stat, go to the quality tools, then capability analysis, and here you select binomial. Click on this, select your defective, which we have this. Sample size is not constant, we have a variable sample size, so we will select the transaction done. Leave rest of the thing as it is and just click on OK. And now this output is generated. So what you will see from this graph, you can clearly see this is the P chart, which is for the proportion defective. How the rate of defective is varying over the sample size. This is the percent defective cumulative, how they are increasing over the period of sample size as it's increasing. And what is the frequency of the defectives in the last graph? What is important? You have to see the center table here. As we were calculating, you can see the percent defective is around 8.78%, which is may range. This is mathematically we calculated. Statistically, it may range from 7.8% to 9.85% based on the 95% confidence level. You can convert this into parts per million. So 8.78%, if you multiply with the 10 power raised to 6, you will get approximately 87,836 DPM. Same 7.80 you convert, that will be around 77,973. And 9.85 if you convert, multiply by 10 power raised to 6, then it will 98,506. Z value process sigma level is 1.3542, and this is what I was telling you, that your sigma level is 1.35. If you go for the further, you have the 1.53542. You look for defect 8.78 if you want to convert into the DPMO level, so that will be multiplied by 10 power raised to 6, and you have the 87,836 defect here. This is the way we calculate the process capability of the binomial data. Next session, I am going to explain the process capability about the Poisson data. Thank you so much.